my introduction has already been done, so you already know that I'm Josiah Carlson. I've included my Twitter handle just in case you like what I say and want to find out what I'm saying in the future. To offer a little... Is it okay here? Or maybe move it up. Is this better? Or even higher? This better?
There you go.
All right. So I'm Josiah Carlson. There's my Twitter handle. That link will become relevant in a few minutes when I talk about it. And I'll also include that information later if you are interested in it then. So this talk is going to cover who I am. It will also cover a bit of an anecdote and revelation. It will cover a bit about what Postgres is good at, perhaps some examples where Redis does well. Then we'll talk a bit about what Redis is, and forgot to add another line because I rewrote the talk in the last 24 hours, which I'll explain why in a minute too, where we'll do a bit of bridging the gap between Redis and Postgres. So continuing on, who am I? Well, I've been an open source contributor for about 9+ years. A lot of it has been related to some personal projects, followed by some work on Redis itself. Not a lot of work on Redis, but a little. Mostly I spend a lot of my time with Redis, interacting with the community, answering So the Twitter handle is actually official. Really just means that I did this. If you know the comic, more or less it's the idea that there's a universe of knowledge, and as you study, you push it out, and then some of us do that little thing, and it's understanding the context that we've done very little, even though we spent so much time doing it. The hope with open source contributions and talking with people is that I and everyone else continue to do these little things, and maybe we can make that circle overall bigger. And all this stuff was as much luck as anything. Hard work, certainly, but a lot of luck. And if you know anybody who has been doing these kinds of studies, you'll understand that a lot of people get unlucky. I just happen to be very lucky. In the past, I've also worked with some cool people at a company called Affini out of San Jose, then at a company called Networks in Motion in Aliso Viejo, then a bit at Google in Santa Monica, where I worked on the YouTube team, and then a little company called Adly, and I'll talk a little bit about my work at Adly, and now I'm at ChowNow, where we do online takeout and delivery ordering. So, I'm also a very heavy user of Python and Redis. If there's a day that I don't or if there's a week where I don't touch either Python or Redis, I probably don't have a computer. I took a 4-day vacation last week where I didn't have a computer, and I still replied to the mailing list on my phone. Which was much to my wife's chagrin. I'm also the author of Redis in Action, which is where that bit is available as of, well, should be available as of Friday. And I've only got one actual chapter left to write. The rest are in the, purgatory between writing and available. I'm also a moderate user of Postgres. I'm probably the least experienced Postgres user who's actually presenting at this conference, which puts me in a relatively unique position, which will become very hilarious in a few moments. So, the anecdote. So I've got this perspective that I should never give the same talk. It's kind of an extreme version of Louis C.K.'s and George. This is only my second actual talk at a conference, third if you count speaking at academic conferences. But so it's not been that difficult. You know, I just throw away the one talk that I gave. But the problem is that I rewrote the talk from 4 weeks ago, and it actually sucked. My original talk sucked 4 weeks ago, and my rewrite sucked. Now, I knew this, and I'm so sorry to everybody that knows SQL Now 2012. I knew this, and I tried and this new one that I rewrote, Postgres. And it's not Postgres' fault. It's totally my fault. I knew this. I tried to fix it, and I failed repeatedly. And as somebody who attempts to succeed, failing repeatedly is not a fun plan to be operating on. And to be honest, I'd have been better off finishing the book and drinking. Because it turns out are really how I came to my revelation. So on Monday night, a few of us speakers were, well, all the speakers were asked to come out to dinner, and then afterwards we ended up at the bar. And so I went to the bar. Jacob Kaplan-Moss was there, Peter Van Hardenberg of Heroku and his co-worker Robert, I don't know his last name, okay. And later, I didn't really know who any of these people were because, well, this is my first conference really where I'm out in the community and really speaking with people. And it was kind of an interesting experience. And Robert offered a question in regards to MySQL. And of course, I offered my standard haterade. And like that version of haterade, it was low calorie, which means that my hate was terribly uninspired. And while there's database, okay, mine was terribly superficial. It offered nothing new to the conversation. It didn't offer any unique insight. And I came to the realization as I was sitting there and spouting this bullshit, pardon my language, that I was from Good Will Hunting, and I was surrounded by Matt Damons. And it was upon that, and it happened multiple times that evening. And I realized, oh my gosh, I'm an idiot. But I had a reason. I've been spending so long working on the book. It's basically 10 months of no evenings, no weekends. I haven't been exploring the world, and my breadth of knowledge with relation to what has been going on in the world has been relatively narrowing. I'd spent years studying as many things as I possibly could, and I stopped because I was working on this one thing, and I became an idiot. Which brings me to, why am I here? You know, after realizing this, and after realizing my talk sucked and I needed to redo everything, why am I here? Well, I'm here because someone wanted me here. In fact, Hybrid DBA, Matt Kiranen, he said, hey, it would be awesome if Josiah came here and talked at Postgres. And it happened. That's why I'm here. And so I need to do better for him and for everybody else who's, you know, unfortunately sitting here in the seats. So that's what I'm going to do. I'm going to do better. And so I realized this on Monday night, and I started rewriting my talk yesterday morning. Only about 25% of it survived, but it was rewritten, and hopefully it's the better for it. So, thank you. Yeah, thank you for having me here. You've all been wonderful so far. Hopefully the rest of the talk will be good. So, what is Postgres good at? Based on my revelation, am I really experienced enough to answer that question? No. I am not experienced enough to answer that question. My total volume of yearly experience is 2.5 years if I lie to myself. And probably only database administrator. It's not as, a database optimizer. It's as a user via ORM. Like my knowledge of Postgres in that context is limited. However, I'm at Postgres Open, where everybody else is an expert except me. So this is a learning opportunity. So what is Postgres good at? All this stuff. Just based on the conference listing of talks, it's great at ranges, temporal databases, replication, high durability for data, WAL-E, which in and of itself makes me want to change every database that I've ever used from MySQL to Postgres, but I'll get into that in a second. PostGIS, JSON, full text search, big data clustering, GIN-GIST, key value, and PL everything. No, that's cool. I can totally switch. Yeah. Yep. Okay, so it seems I got to stand over here now. So it's great at all these things, but given my revelation, and my limitations, am I really qualified to talk about where Redis can help? We'll leave that at a maybe. We'll see what you think afterwards. So, what are some limitations of Postgres? Well, Postgres is pretty fast, and you can tune it to go even faster. 9.2 made this even better with the tweaking of locking and all that other behavior, so that on that beautiful 64-core machine, you could do 350,000 reads a second. Amazing, phenomenal. And with a little bit of tuning with fsync and whether or not you're going to have a WAL file and even your WAL file sync options, you can make your writes go even faster, potentially even the speed of your reads, depending on your write volume and read volume, all that other stuff. You can't go faster than disk speed. No technology is magic. But the layers between your query on the client and when it's actually executing on the server and then the transformation back to the client is a lot of layers. Now that's a layer cake of, well, I'm not going to mention what it is, but it's a layer cake of stuff. A lot of transformation that needs to go on. And as a result, most queries to the database are not dominated by network latency. Okay, they're dominated by actual query execution and transformation and all that other fun stuff. Also, Postgres' support for more data types is quite amazing, okay? Unfortunately, not all problems fit Postgres like a glove. A lot of them are really like a loose backwards sock. You try to fit it in your shoe and you're like, it doesn't feel quite right. You never know why. Well, it's because your data model doesn't fit. And having used a few different NoSQL databases, I'm generally of the opinion you pick your data store to fit your problem. And most people are like, well, if I want my data to last forever, I stuff it in Postgres. If I have certain types of data access patterns, maybe I store it in a document store, whatever. And that's perfectly reasonable. But just because you have particular access patterns still doesn't mean that your data fits it well. And generally, a lot of this stuff goes that way because all data models are unique snowflakes. And even worse than data models themselves being unique snowflakes, everyone has a different interpretation of how that should be stored. All the different normal forms suggest ways of doing it, but they're not always the best. And there may not be the best for the particular application based on data access patterns, having to reference foreign tables and things like that. Josh just had a talk this morning on data warehousing where he talked a lot about that and having data in external tables and stuff. And that's relevant regardless of whether or not you're doing data warehousing. So what is Redis and how does Redis change these kind of things? Well, Redis is an in-memory data structure server. It maps from keys to structures, and the structures can be one of 5 different types. Strings, which are not just strings, they're also integers and floats, and you can access strings via byte ranges, read and writes, or individual bits, if you're into that. You can also have lists, sets, hashes, and z-sets or sorted sets, which are like a hash, but you can access the values by sorted order of the values, and all the values must be floats. Redis also has support for publish subscribe, a bit like the notify listen that you may or may not already be familiar with in the Postgres world, only it's significantly more scalable because it was designed to be. Redis also has persistence to disk from memory via snapshot or via append-only file. And these append-only file can sync with every write to Redis, or can sync every second. If you sync every second and you're not moving more data than your spinning disk can handle or your SSD can handle, this actually has zero performance impact. And I can even show you that in a second. And generally, Redis offers 300,000 or more pipelined reads and writes per second on one core. And this is on a relatively low-end machine. I'm going to swing over a virtual machine that I have connected to a 2.4 gigahertz box sitting under my desk at work. And what I'm going to do is I'm going to run the benchmark, and that is 5 clients performing a total of 500,000 requests with a pipeline 100 deep, which is not uncommon for certain types of data requests. Although even if you're not pipelining, if you're just making a lot of other types of requests, you can do close to this amount. And the queue just says, just spit me out the final results. And we watch it run, and it's doing 480,000 sets, 750,000 gets, 550,000 increments, almost 700,000 list pushes, almost over 700,000 list pops. And yeah, it's pretty fast. So the quick reason, or the 2-second reason why you might want to use Redis is that it's really, really, really fast, okay? Now, getting data in and out is really what Redis is about. You put data in as fast as you possibly can, and you fetch it as fast as you possibly can. And depending on your AOF, again, you can do that many reads writes per second on a relatively low performance machine. And that box that I was showing you has actually got AOF enabled, and it's running, and the spinning disk in there is an old 80 gig spinning disk, so it's slow as crap. And it's syncing every second to disk, and even though it can still run that kind of performance. Redis also supports server-side scripting with Lua, which offers a few advantages depending on your application. It can simplify applications greatly. That's of Redis 2.6, which is in release candidate 7 now. There have been some recent patches, which means that release candidate 8 is maybe a month out. And hopefully, in the next couple months, will be generally available. There are a lot of people who've been running Redis 2.6 release candidates 6 and 7 for months in production, and it's been working great for them. I haven't yet because I'm very conservative when it comes to software upgrades. Redis also supports replication via master-slave and offers slave chaining or coalescing or that kind of thing in the Postgres speak. So you can do slave chains and slave trees and things like that. Don't try to do circular replication where you make one a replica of another, or you set them up in a circle. That is not multi-master replication. That does not work. If you try to do it, you will have a bad time. Things like quantum writes, where things may write, may not write. Generally speaking, you will have a kind of resync operation happening effectively, continuously. You will use all of your processor and all of your network, and perhaps even all of your disk I/O on all the boxes in this thing. Just don't do it. So let's look at an example of Redis actually being used and how we might get to use it at some point. And the quintessential problem I like to look at is what I call event analysis, maybe a bit like Google Analytics, where you're trying to come up with some, X number of events happened in this time period, and you want to do this for a stream of incoming events. Well, maybe at first you think, oh, well, maybe I should just put everything in the database. I mean, I've got everything else in the database. I could totally do that. And you do that until, well, you run out of I/O, or you have to start doing some fundamental big changes to how you're storing your data in order to get all of your data in. So what is the common change you do? Well, maybe you go and you stuff it in a document store, because isn't that what document stores are for? Or maybe even you log those to flat files. I'm a big fan of logging to flat files because you can put as much data into it as you can imagine, and it will work just fine. Again, limited to spinning disk, or SSD I/O capabilities. But then in order to analyze your data, you have to go and you have to set up your MapReduce. That's the thing to do, which works great until the amount of time that you perform your MapReduce takes as long as your data collection. So say you start running it at midnight, and it takes until midnight the following night to finish. There was a period at Microsoft, from what I understand, that the time it took, their code had gotten so large that the time it took to compile Windows and all the associated libraries took more than 24 hours. So you couldn't even get a daily build anymore. Well, it's the same kind of thing that happens when your event data increases to some extent. Well, you can always add more machines, right? But then all you've done is kicked it down the street a little bit, And the biggest problem you run into with MapReduces is not the fact that, hey, it takes a lot of processor to process on. It doesn't. Processing data as part of a MapReduce is typically the least amount of effort that goes on. Most of your time is spent writing the data to disk when it comes in, and then reading data from disk later, and then distributing it across the network. You've got all this I/O that is completely worthless. So get rid of it. Start stream processing. Stop MapReducing, stream it. Handle it in real time. That way you get more up-to-date counters, you handle it in real time, and you have a pretty good idea in advance, oh, wait a second, we're going to need a bit more capacity for these 8 hours during the day when we have higher load, so maybe you can spin up more boxes, or you just have a little bit more capacity that can handle that, or you just batch up that extra stuff and you handle it a little bit later in the day. But now you need a stream processing system. Oh my gosh, but you've already got one. Syslog, syslog-ng, Flume, and all these other things are a pluggable real-time streaming platform for processing. You've already got logs. You're already spewing logs into these systems. Just stream that stuff to disk, and in addition, bypass it off the network and pass it to a stream processor. And you can even run these stream processors on the same box in which the logs are being produced. Of course, that's me being devil's advocate. But the problem is that you need a destination for your analytics. Now you're processing them. What are you going to do with all these increments on your counters? Well, you could go and directly write them back to the database, but then you're going to be running into your potential limits on updates. But I would argue, use Redis for your aggregates. I just showed you that one box, one slow box that was actually made 4 years ago can handle some 400, 500,000 writes a second. Use that to store your aggregates, or use that to create your aggregates, and then later you can sync out to Postgres or whatever your long-term storage for this if you want. Me, I just leave it in Postgres because I don't really need a lot of counters. My number of counters is perhaps in the thousands, and I can just leave that in Redis. Okay? Let's look at a couple other problems, and we'll move through these pretty quick. Redis is a search engine. Now, this is something that I actually did, and this was my first product and project in Redis. We needed an internal and externally accessible search product that had support for 100,000 user profiles, nothing too bad. 10 or more filtered attributes, okay, also not so bad, but also offered full text search. Okay, we can do that, that's not bad. We had an existing solution. It was a SQL query composed via ORM against Postgres 8.2. And unfortunately, due to our own fault, it took 3 to 6 seconds to query even without the full text search. And when we added full text search, it also added more time, but it also gave us crap results because, well, we didn't know about Postgres's full text search capabilities at the time, or we didn't use it or something. But part of the reason why it took so long is we had data that wasn't in one table. We had data on multiple tables, and there were foreign key stuff, and maybe we weren't indexing right.
We didn't spend a lot of time on it. We spent a few days and we realized, wait a second, we don't know crap about Postgres. We heard about this thing called Redis, maybe we'll give it a shot. And so we did, we gave it a shot. And using Redis, my first project, 2 to 3 weeks to full production rollout. And it took 15 milliseconds to query it. We got all of our search stuff, came back in 15 milliseconds, which wasn't bad. Earlier versions of this talk that I gave, I said 50 milliseconds, but then last night in a drunken moment of clarity, I realized I saw in my mind 14.759, a few other numbers, and I realized, wait a second, that was the amount of time. At least that's what I saw in my head, so we're going to call it 15 milliseconds. If you convince my former employer to let me have access to the code, I can benchmark it for you, and some data. Also, we updated the index via ORM post-commit hook, which worked quite well for us. And later, we refactored this to offer internal support for searching over all of our database entities of all types. And that ran on our search Redis box. And we were very, very happy about it, and it even got faster. So after this, we had such great success, and we had a business need to build a content and location-targeted ad engine. So we needed to target ads based on the content that were being sent to it. Some of the requirements were basically we needed to have AdSense for the stream. Okay, so if you know what AdSense is, it's an ad product that is produced on web pages, and the content of the ad, and the ad is targeted against the content of the web page. And so we needed to build that only for like Twitter clients and Facebook clients or things like that. Our only major limitation was a 200 millisecond deadline, which based on our experience with Redis in the past didn't seem to be an issue. So we used Redis. And within 1 month, we had a proof of concept that actually worked pretty well. It even did, in addition to content matching itself, we categorized content and matched against categories of both content and ads. It took about 2 weeks to productionize. And internally, we had about 20 millisecond internal query times and 50 millisecond external. So 20 milliseconds on the Redis side of things, and then another 30 milliseconds for everything else, which included content categorization and things like that. The kinds of things that the ad engine supported were little things like second price auctions, value-based learning, budget that lasted throughout the day, which even some of the big people have problems doing now, and all of the typical ad engine supported features. And this worked, and it worked great for a while, and then we realized that we could not scale the business, so it was mothballed, which was a very, very sad day. That same week, my code at YouTube had been deleted, all of it. So it was a rough week for me. But that's okay, because after we finished the ad engine, we had another project that ended up being in Redis, and that was Redis as the storage for a Twitter analytics engine. We had a few simple requirements. We needed a follower graph for popular users, that is the network graph. We also needed follower growth histogram for a variety of users. We needed gender and location demographics for followers and in aggregate for a particular user, for all the big users. And we also needed this concept called follower overlap, where if you have 2 people, how many common followers do they have? Using Redis, and I'll explain in a second why we ended up using Redis, in addition to the, hey, we're putting everything in Redis kind of thing. Basically, we built a basic engine in 2 weeks. It was partly due to the fact that Redis is, we didn't have to do a lot of planning in advance for schemas. Anytime we had an idea, well, we could store data like this. Okay, screw it, we'll just store it like this, and we need to change it, we'll change it later. We built more functionality every single week. And one of the nice features, we ended up getting gender and location information for 85% of users with 90 to 95% precision, which we validated against some hand-analyzed 2,000 users, which was kind of a pain in the butt, but we did it. Now, why Redis here? And the simple reason is because at our peak, we could see some 75 million pieces of information streaming in from our queries every hour. That is over 20,000 writes a second. Initially, we had written everything to Redis, and then when we couldn't buy boxes with enough memory, then we changed the way we stored data. And we pulled that part of information out, but then when we needed to perform aggregates, we were still storing gender and location information in Redis because we were still getting a huge volume of updates on that every second. And then when we were reading, for, at the time, Kim Kardashian was our biggest user that was in our system, and she had 12.5 million followers. And so we had to pull 12.5 million pieces of data out of Redis in order to perform aggregates on it. And Redis worked great for that. We could calculate that in under 5 minutes, which if you think about pulling 12.5 million pieces of unique information out of a data store in 5 minutes, random reads, that's not bad. And ultimately, we ended up producing nice little graphs and pages that look kind of like this. This is Snoop Dogg on Adley Analytics, where we could see how many common followers he shared with 50 Cent, Lady Gaga, Eminem, and a few other celebrities. And we could also go and calculate things like aggregate location information. Turns out that 8.3% of Snoop Dogg's followers are in California, which looks to be a little over 1.5 times the Twitter average. And we did this for all of our big users, and we were very happy with it. And these graphics are actually from a blog post that I put out about a year and a couple months ago in an attempt to gain some sort of publicity and maybe get our company bought. It didn't get bought, for good or ill. That's startup life for you. So these are some other problems that people have solved with Redis. Not all of them are the best solutions with Redis, but people have chosen to solve their problems with Redis for these things because they saw unique capabilities available in Redis for them. And my personal favorite is cookie storage. If you're using secure cookies, stop. And I say that because most libraries that are doing secure cookies are not written by people with any sort of crypto experience, and so they probably are not doing it right. And I say that as somebody who has done a little bit of crypto stuff and who built secure cookies that I could prove were safe and secure, and I stopped. Instead, I just use a single UUID cookie on the client, and I use that for lookup in Redis on a variety of different kinds of cookies, for login cookies, cart cookies, things like that. In addition to removing the crypto requirement, you also reduce the amount of data you're sending from the client from your up to 4K cookie to almost nothing. So stored cookies on the server. I like using Redis for this because it doesn't matter how many users I have, Redis will keep it up. The only company that might not be able to do it, well, actually I heard about a company last night that had 5 megabyte cookies that they were storing on the server. Yeah.
It's not a cookie anymore.
Yeah. Indeed. But if you don't need, as long as your cookies are reasonably sized, you can totally do it. The only company that probably can't do it right now is maybe a company like, say, Amazon, or Twitter or Facebook, in which case, well, maybe you actually could. You just shard your cookie space. That's not bad. So what kind of things does Redis do really well? Well, Redis is really good at things when your data model doesn't fit in a relational model very well. And incidentally, as long as it's also not a document store. There are document store databases. Redis doesn't do any of that. Redis is a data structure server. And so if you conceive of your data as fitting within data structures, great. Also, Redis works very well if you have high I/O requirements. Again, you're limited to your network bandwidth and your disk bandwidth if you're doing append-only files. Redis is not magic. If you learn about a technology that claims that like, oh, such and such is magic. You don't have to worry about I/O issues. You know, they're lying. And if they keep saying that, then they're just lying more. Nothing can go faster than spinning disk or your SSD. Nothing can make that inherently faster. And if your data fits in memory or your problem can be sharded, Redis can do quite well at that. Redis right now doesn't offer server-side sharding. It offers client-side sharding. When Redis cluster comes out, and I don't have a guess for when this is going to happen, Redis server will actually handle a lot of the sharding, a lot of the saying, hey, you're hitting the wrong shard. You should totally hit this other guy to get your data or to write your data. And it will also offer, automatic failover and automatic, data is replicated multiple times and things like that. It is the promised land of Redis. It's not done yet. Then also Redis is good when you understand Redis's limitations when it comes to data durability. If you're coming from a relational database background, which almost everybody is, the data durability is, well, you write to your database and it's there later, unless you have some major hardware failure. Well, Redis's data durability is, if your process dies, you'll have the data since the last snapshot or since the last thing was written to the append-only file. And if you got a partial read on the append-only file, maybe you'll have to clean that out with the utility that is included. But you'll get up to that point. You should be backing that stuff up, just like you back up your database dumps, your wall, and things like that. And there have been some companies that have used Redis as the only store for certain types of data and have been very, very disappointed when their machine disappeared from the world and they didn't have their data anymore. That example where we stored all of our Twitter analytics data, that was the only source for a lot of that data. At 3 a.m. every night, we synced a disk, backed it up to S3, and called her good. And we could recover a day's worth of losses in about 6 hours. Or if we lost all of our data, we would just lose historical data, and we could basically recover everything up to that point in about a week. So for us, every day wasn't a big deal, and we didn't even bother using AOF. But if you care about that kind of stuff, understand Redis's limitations, please. We don't want to get emails on the mailing list saying, hey, I forgot to do a dump, I forgot to back it up, what can I do to get my data back? The answer is you can't. So yeah. So really, what is Redis? I mean, we talked about its capabilities, its features, and things like that. A fellow by the name of Felix Gallo mentioned on the mailing list a couple weeks ago, Redis isn't a database. It's a database construction kit. It has a lot of the features of a database if you twist your mind around them, okay? Because the data model in Redis is so different than any other data store out there, you have to perform some mental contortions to fit your data in there. If you're coming from a programming background, the data structures will be terribly natural to you. You'll say, hey, this is like I've got an app server with data structures that are persisted. And that's really what it is. But I would actually go a little bit farther. I would say that Redis is certainly a database construction kit. It's also a cache server, okay? It's also a messaging server. It's an aggregate server. It is many, many things. In fact, I would actually make an argument that Redis is a shared memory API server. There are startups that are spouting up on both coasts and in the middle, which say, hey, stop writing databases. You should just be making API calls to your database, and you should be accessing it via this document store API, and maybe you can write some extra stuff. You need to do some complicated interaction in there. Well, Redis is already that. You've got your simple data access methods, and then you've got your complicated data manipulations via Lua. Okay? Well, if that's what Redis is, where you can manipulate data via data API, and you can manipulate your data via a code API, well, isn't that kind of like Postgres? In a lot of ways, Postgres has just a different data API. You know, you're using SQL instead of a text-based query language. You've got kind of a different but kind of the same code API via PL-Lua. You've got different data storage types and semantics, but it is still, you're storing data in some structured format. So maybe we should just stop calling them databases. Maybe we should instead call them data API servers. You know, they just have different APIs, and there's different steps that you go through to get from what you want on the client to the query that you're making to the response. But this is kind of what they really are. And the answer for when should I use Redis? Well, you should use Redis when it makes sense to use Redis. And I'm not going to give you tools to do that. You have to do it yourself. You have to decide for yourself whether Redis is a good idea for you. And there will be times if you ask on the mailing list, if you say, should I use Redis for this? And I will say no. People have this idea that if, you know, advocates or people who use it, or even people who are writing books like me, when they say, hey, should I use this for this? Or should I use Redis for this? It's not for everybody and it's not for everything. I still have a relational database. I use Redis for the canonical data source for cookies because if I lose my cookies, then people have to log in again. You know, but for many other things, canonical source is database. So yeah. And with that, are there any questions?
Can you talk a little bit about, I mean, for those of us who are not familiar with Redis, you were talking about how coming from like a programming background, the data types and structures would be natural. Can you speak a little bit more towards how they're different from like the Postgres thing?
Sure, sure. So the question was, can I explain the difference between the standard relational table model versus the Redis data structure model? So in a relational database, your typical access and your typical storage are tables of rows. The simplified version of that for somebody who has no idea what they're talking about is it's like a spreadsheet, right? Now it's super, super, super simplified and not the truth at all, but it's kind of like that. In Redis, you don't really have tables and you don't really have rows. Now you can emulate tables and rows if you think of them as, well, a row is really a series of data that is associated with named columns, right? Well, a hash has named keys and values. And so a hash is kind of like a single row in a database table, okay? And a list in Redis, an individual list in Redis, is like a list from your programming language stuff. And a list in Redis you can think of as a Postgres array with no other associated data in that row. Okay? Now there are some convenient manipulations for it and blocking pops if you want to use them as queues and things like that. I've done that many times. Thousands of people are doing that. GitHub is using, that's basically resqueue. It's basically just using lists as queues. The strings are basically just arbitrary C-style strings with access methods that are more or less the same as typical standard C-style character strings. You can access via range, you can read and write via range, you can fetch individual bytes, you can read and write individual bits. That is actually one of the big things that I talk about using it for reducing memory use in chapter 8 of my book, which is pack your data in a structured format and store it in Redis rather than using keys and values and using some of the other more complicated data types. Sets are exactly what you would expect if you understand set theoretical mathematics. You've got unique items, and you can perform set intersection, set difference, and set union on them. And they're actually quite phenomenal, and if you know what inverted indexes are, that is, you can use Redis sets to implement a GIN-style index, which you then use to manually intersect. So you can build a search engine on top of Redis because Redis includes the structures necessary to build it. Now, one of the things that you have to be aware of is that some of the structures are still more or less first passes of what has been around. Some of them could be made faster or more concise in terms of memory use, but they work, which is why they are exactly the way they are, even after several years. There are some memory optimizations that have been done for small structures, but if you use big ones, realize that they're going to use more memory. And then finally, sorted sets. Sorted sets have the same sort of intersection and union operations available to you, but you still need to merge scores. And there are 3 options for it, yes, 3 options: min, max, and sum. So if you're combining scores from 2 different entries in a sorted set, you can either use the minimum of the 2, the maximum of the 2, or the sum of the 2. You can also assign weights to the values in each of the input sorted sets. You can say this one is worth twice as much, this is worth half as much, this is worth a third as much. And using that method, if you can tort your mind around a little bit, you can actually do more or less arbitrary query weighting parameters. Like I've got a blog post from, I think, almost 2 years ago now, where we built TF-IDF-based scoring on a document search with Redis. And like I was mentioning, our ad engine supported quite a variety of weighting. And in the book, in chapter 7, we actually build an ad engine from scratch where we include automatic learning, Bayesian-style learning, and location and content targeting as well. Or no, do we do content targeting? I can't remember. We do at least location targeting. But yeah, that's in chapter 7, where if you really want to learn the basics of search from a fundamental perspective, it's not a bad introduction. And if you've never seen search before and you're interested in it, of course, to buy the book for that one chapter may be a little bit much, but I claim the book is good. Any more questions?
So how different Redis from NoSQL?
So the question was, how different is Redis from NoSQL? So NoSQL is a group of technologies whose only attribute is that they don't implement SQL query languages. They implement their own. And Redis, being one of these databases that don't offer a SQL query language, fits within the cluster of NoSQL databases, which is why I was at NoSQL 2012. That said, if you really like Redis and you really like all the data access methods and you love Lua, if you really want SQL, there is a database called AlchemyDB, which is a fork of Redis that adds a SQL query language to it. And you do stored procedures in Lua with it, and it's actually pretty phenomenal. And the guy who wrote it, his company just got purchased, and so he was down in South America. Now he's in San Jose. A guy named Russell Sullivan, very, very, very smart guy. And yeah, so if you want SQL in your Redis, that's the answer, AlchemyDB. Other questions? All right. Well, obviously I'll be around for a little bit longer if you guys want to talk afterwards. And if you really want my card, I'll give it to you. I really love the design. We had a great designer design these bad boys, and I had to get an extra 500 of them. I'd had some old cards that sucked, but these are amazing. So yeah, thank you, and